Today we are going to learn about image formation by the plane mirror. Maybe you don't know, maybe you know, but let's understand how the image is formed and you can draw the ray diagrams as well. Point size is like a zero dimension, just a single point. If you place a single point in front of the mirror, how the image is going to form. For this point size object, I'm getting the image at a behind the mirror and it is also a point size image. So 1D object is like, for example, this pen. This pen, you can consider it to be a one-dimensional object. So if you consider this as your 1D object, there is a one-dimensional object. So for this, we'll get a corresponding one-dimensional image. What is a 2D object? Object which has length as well as height. 1D object is, it has only height. So now it has length as well. Shape or the size of the object and shape and size of the image, they are exactly equal. But what is different? It is the laterally shifted. There is a lateral inversion, right? Right becomes left, left becomes right. That is the only difference. Real images, they are inverted. Inverted meaning, if let's suppose there is an object, you get the image which is like this, ulta, right? Whenever you get an image flipped, that is an inverted image. This is an inverted image. And what is erect? It means, let's suppose there is your object and behind the mirror you see there is your image. So it is not flipped. Vertically there is no inversion. So that is called as erect image. So it is always virtual and erect. Hello, hi everyone. So welcome back. So today we are going to learn about image formation by the plane mirror. Plane mirror is very easily available. All of us, we have at our home. We can see our image, right? If you look into the plane mirror, we see our image inside the plane mirror. But do you know how the image is formed? Maybe you don't know, maybe you know, but let's understand how the image is formed and you can draw the ray diagrams as well. Alright, let's begin. So this is about me. If you are seeing me for the first time, I have a PhD in physics from Singapore, BSMS dual degree from IISER Pune, ranker in JEE Advanced and 7 years of teaching experience. So let's start. Now, let's consider a very easy case in which we have a point size object. Do you know what is point size object? In the last class, I told you, point size is like a zero dimension, just a single point. If you place a single point in front of the mirror, how the image is going to form, that we are going to learn. For example, here, this is our O is our object or the point size object. So from this O, it can be a source of light or can be any reflector. For example, you are able to see me. Am I a source of light? I'm not. But what happens? The light coming from this tube light falling onto my face, getting reflected towards you, right? So this object, it can be either a source of light or it might be reflecting the light, correct? So it can reflect the light in all the directions. Light can go out in all the possible directions, correct? Now, some of this light might be falling onto the mirror. So this one, PQ, is our mirror. So some rays of light falling onto the mirror. For example, let's consider two of them. This OA and OC. So these are the incident rays. They fall at these 2 points A and C. So what are these called as? A and C, they are called as point of incidence. Now this one here, this AX and CY, this AX and CY, these two are normals, right? So here this one would be your angle of incidence I. Now this incident ray is reflecting here. This is your angle of reflection R. Similarly, this another ray, this is your another angle of incidence and another angle of reflection. So these two, they are reflected ray. So they will reach to your eye. They will reach to our eyes. So we are able to see some rays coming towards me. So I should be able to see the object, the image, right? So where I am going to see the image? These rays, they are going away from each other. That means they are diverging. So whenever rays are diverging, what we do is we extrapolate them backwards. We consider them backwards. We go behind the mirror. So this is the side which is, if there's a mirror, there's a front side, and there's a back side of the mirror. There's a front side of the mirror, back side of the mirror. So you go behind the mirror and you find out that there is a point, this point I, where these two rays, they appear to meet. So these reflected rays, they appear to meet behind the mirror. Again, read my, understand my words clearly. They appear to meet. So whenever you see this word appear, that means it is a virtual image. Whenever you see this word appear, it means it is a virtual image. Okay. So now, here in this case, what is happening? For this point size object, I'm getting the image at a behind the mirror, and it is also a point size image. Point size object, point size image. It is behind the mirror. Now let's consider a larger object. Let's suppose a one-dimensional object. So 1D object is like, for example, this pen. This pen, you can consider it to be a one-dimensional object. So if you place this 1D object in front of the mirror, so how the image is going to form, that we are going to learn now. For example, you can see here, this AB is our object. This is our one-dimensional object, 1D object. Yes. So here, when you have one-dimensional object, what we do is, there is a tail and the head. So this A is, you can consider to be head, and this point you can consider to be tail. So you can represent it by arrow, right? There's an arrow. So here, you can draw a line. There's a point B which is a tail. From the point B, you can draw a line perpendicular. So there's an imaginary line which is perpendicular to the mirror. This one is our plane mirror. There's an imaginary line perpendicular to the mirror. Just draw it for now. Now, from this point A, you can consider any two rays. There can be infinite number of rays coming out from this point A. You just have to consider any two rays. Any two rays will be sufficient. So first ray, it is along the normal. First incident ray along the normal. So there is a normal here. So what will happen? This would be the reflected ray. There is a reflected ray. Now there is a second incident ray making an angle I. So this would be the angle of reflection, and there is another reflected ray. Now these two reflected rays, they are again going away from each other. If they are going away from each other, so what do we understand? If these two rays are going away from each other, that means they are never going to meet. So in that case, again, we extrapolate them backwards. We go behind the mirror. So this region is behind. This is front, correct? So when we go behind the mirror, what we observe? We observe that they appear to meet at this point A prime. So for this point A, what we are getting? We are getting the image. There's a A prime, there's an image. Okay. So similarly, you can draw for this point B, you'll get the image at B prime. So for each point here, like there are hundreds of points, right? There are like millions of points here. For all these points on this segment AB, you will find out the image is going to form at all these points, right? So if you consider this as your 1D object, there is a one-dimensional object. So for this, we'll get a corresponding one-dimensional image. So there are certain properties we can understand here. The first property is This u is called as object distance. So it is a distance of the object, distance of this object from the mirror, this much distance, and v is the image distance. This is your image. So distance of the image from the mirror, that is image distance, right? These two are always going to be equal. So object distance is equal to the image distance. This is valid for the plane mirror. Object distance is equal to the image distance. Now there is something else, that is, can you see this object? This, let's suppose you can call it as a height of the, this height of the object. HO is the height or the length of the object. Now exactly same length here is the height of the image. So height of the image is exactly same as height of the object. And why is it true? If you look into the mirror, you have a mirror in your home. When you look inside the mirror, what do you see? Our face as it is, right? So what does that mean? That means the image is same size as the object. Image and object, they are same size. So you can write height of the image is equal to height of the object. This is valid only for the plane mirror. So whenever you have a plane mirror, all these are like this object distance is equal to image distance and height of the object equal to height of the image. Clear? Now let's understand a complicated situation. Let's say you have a 2D object. What is a 2D object? Object which has length as well as height. 1D object is, it has only height. So now it has length as well. So you can draw, let's suppose this is a mirror. This is your plane mirror. Let's suppose this is your object, right? It has this point A, then this B, and this is C. So whatever we have learned till now, we are going to use that. First one is from here. What is this distance? There is an object distance for this point C. Yes, for this point C, you'll get an image at a same distance. So let's call this as a C prime. Now there is a point B. So this would be your object distance here. You draw exactly same length somewhere here. This would be your image distance. For this point B, at the same line, you'll get a image somewhere here, right? Somewhere here. There's a B prime. And for this A, you can get an image somewhere here. There's E prime. So just connect these dots. So if this is an object, for this object, what we get is there's an image. So again, all of them are same. Like for example, this distance, object distance is equal to image distance, right? Here also this is the object distance, there is the image distance. But there is something very different. Let's suppose if you look at the object, what do you see? The C point is on my right. Can you see? This C point is on my right. B is on my left for the object. But for the image, the B prime is now on my right and C is on my left. So what we are observing? We are seeing a lateral shift, or it is laterally inverted. So whenever you get an image of the 2D or 3D object, there is a lateral inversion, right? You can understand it. For example, in this figure, when this is your right hand, if you look into the mirror, your right hand becomes the left hand and your left hand becomes the right hand. That is called as lateral inversion. So because of the plane mirror, everything else, for example, the shape or the size of the object and shape and size of the image, they are exactly equal. But what is different? It is the laterally shifted. There is a lateral inversion, right? Right becomes left, left becomes right. That is the only difference. You can clearly see here, object and image, Everything else is same. Image is virtual, same size as the object. The distance is also same. This distance, object distance and the image distance, they are also same. Just that it is laterally inverted. Now let's solve some questions based on this. First question, image formed by a plane mirror is. So what are the properties of the image formed by the plane mirror? First is virtual. Is it virtual? Yes. So that this could be correct. Real? No, it is not real. So this is not correct. This is also not correct. Now in between these two, behind the mirror, that is correct. Behind the mirror, that is correct. Then it is enlarged. Is it enlarged? No. Same size as the object, that is correct. So this option is correct option. These are the properties of the image formed by the plane mirror. Now, there is a difference between real image and the virtual image. So what is real image? It is formed when the light rays, they actually meet. Light rays should actually meet. That is the real image. What is virtual image? Formed when the light rays, they appear to meet. Light rays, they appear to meet. They are not meeting like in reality. They appear to meet. So when do they appear to meet? It is mostly behind the mirror. So real image, it can be obtained on the screen. So for example, cinema screen, we get a real image. And this virtual image, you can't be obtained on the screen. So the image which is formed by the plane mirror, it is behind the plane mirror. So you cannot get it on the screen, right? It is behind the plane mirror. So that is, example is image formed by the plane mirror. Now there is one more difference. Real images, they are inverted. Inverted meaning, if let's suppose there is an object, you get the image which is like this, ulta, right? Whenever you get an image flipped, that is an inverted image. This is an inverted image. And what is erect? It means, let's suppose there is your object and behind the mirror, you see there is your image. So it is not flipped. Vertically, there is no inversion. So that is called as erect image. So it is always virtual and erect. Virtual and erect always go together. Then real and inverted, these two always go together. Clear? Now let's solve this question. Okay, question is, why the word ambulance is written as shown in this figure? You must have seen, right? In this ambulance car, this ambulance word is written, it is not very easy to read. But why it is written like this? Let's read the options. Image in the mirror is laterally inverted. Image in the mirror is vertically inverted. It is easier to read. None of the above. It is definitely not easy to read. Now what is lateral inversion? Let's suppose if you place a mirror at this point, then this one is a lateral. There is a lateral inversion. If you place a mirror somewhere here, if there is a mirror, then this one would be a vertical inversion. So let's suppose there is some car which is in front of this ambulance. So it will have the mirror something like this, right? There is a car in front of the ambulance. So this E will appear something like this. Then C will appear like this. Then there's N, then A and something like this. So can you see? You are getting this correct spelling. L, then U, B, M, A. Ambulance. So that is what? It is laterally inverted. Image will become laterally inverted. If you write this correct sentence, then in the mirror, you will see this word, which is not easy to read. But if you write that on the vehicle, on the ambulance, you will get a correct spelling. So that is the right option. Now, let's solve one more question. So here we have object height 5 centimeter. So there is an object height 5 centimeter at a distance of 3 centimeter. So this object which is a 5 centimeter in height It is placed at a distance of 3 centimeter from the mirror. This is your plane mirror, right? So which of the following is true? And it is multiple correct. Choose all the correct options. Now how you solve this? There is an object distance. So image will form at a distance of 3 centimeter. So there is an image distance. And height of the image same as height of the object. There is an image. So image will also be 5 centimeter in height. So which is correct? Image is formed 3 centimeter behind the mirror. That is correct. Formed 3 centimeter behind the mirror. It is correct. Formed at a 5 centimeter behind the mirror. This is not correct. Image is erect with height 5 centimeter. Even this one is correct. Can you see this image? It is erect and it has a height of 5 centimeter. So this is correct. Image is inverted. That is not correct. Clear? So this is how you can solve the question based on plane mirrors. Alright, so that's it for today. Thank you so much everyone. Bye bye.